So we've talked about adding, subtracting, multiplying, and dividing functions and composing functions. This third part of this section belongs with the composing functions, but we're doing it kind of backwards. So this is called decomposing functions. So you'll have a complicated function and you try to decompose it into the composition of functions. So write phi of x equals cube root of x squared minus 1 as the composition of three functions, none of which is the identity function. The identity function is I of x equals x. In other words, y equals x. It's the identity function. X and y are always the same. We don't want to use that function because you could just use it over and over again and it would be silly. It would make the exercise silly. Okay, so solution. Put the functions in the order in which you would evaluate the function. So the input is the same for each step. You'll see what I mean when I do it. So in this one here, in phi, if I were to evaluate this for some value of x, first I would plug the x in here, then I would square it. So the first thing you want to do is square. Then I would what? I would subtract 1. So the next thing is the subtract 1 function. Then I would do a cube root. So the next thing is a cube root function. This is similar to when we were graphing, doing the transformations, except that we do the cube root. Instead, when we're doing the transformations, we were taking the cube root as giving us the basic shape, right? So this is a little bit different, but it's still the same order. So I wrote this out. I kind of color coded it. If you don't see colors very well, hopefully you can kind of see the different shades. So starting from x, we get our first function would be f of x equals x squared. You can use any letter for f rather than f if you want. I just picked f. Okay, f of x equals x squared. You don't want to use phi because it's already being used here, right? So I used f. There's three of them, I'll probably use F, G, and H. That's pretty common. So that would be the first one because that's inside. Now the next one, you want to subtract 1 from x. So this is what I was saying up here. The input is the same for each step. So we're using the same letter is what I mean, which is x. Okay, so when we're adding 1, the second one, we don't put x squared minus 1 because we're going to compose these in the composition. And when we compose them, this will get stuck in here, and you'll get x squared minus 1. This will be substituted in for this x. Okay, so it's always, you do something to x. So after squaring it, I want to use the subtract 1 function. So subtract 1 from what? Subtract 1 from x. That's all I'm thinking, okay? And then next I want to use a cube root function. Cube root of what? Cube root of x. So h of x equals cube root of x. Now I need to compose them, and I have to say which order I'm composing them in because it makes a big difference. The order will be, well, I would write it out. I was just putting them all three together. So the answer would look like this. List the three that I found, and then phi has to tell me what order to do them in. Now remember, this means that you do f first, because it's f of x. It's h of g of f of x. So f of x is the inside function. So you do f first, then G, then H. So I'm going to, right? So that's the order I did these in. F first, then G, then H. F, G, H. And the first one always goes next to the X, so it looks backwards. You have to read out from the X, not left to right. So if you don't state the order in which they're composed, then you haven't done the problem. Okay. So that's it with that section. Just work on this a lot. If you get stuck on something, ask me or a classmate or a tutor, because it's really important to get this stuff done. Once you've got it down, it's really easy, but it takes a little bit of time to get all this stuff down. So just do a lot of practice problems until you've got them where you don't miss any and where you understand fully what's going on. If you don't do that, then every time you see composition, you'll like freak out. And you don't want to do that. You want to be nice and calm and, confident.